Okay, ladies and gentlemen, we are talking post-quiz, the Pythagorean Theorem on lesson 10.5. This is probably one of the things that I have personally used the most skills that we do in algebra this year. I used this while I was working construction, trying to square things up. So here we go. These are reminders of how to do things from lesson 10.4. And yeah, these are pretty sweet. They're pretty sweet. I know you guys are excited. So we're going to be using scales from the square root property. You should have a little bit of background knowledge about the Pythagorean Theorem. So hopefully this will be a nice, quick, and easy thing for us to all be like, oh yeah, I remember doing that. So here we go. We have new vocabulary words, the hypotenuse. I've been told that you have no idea what this is. The hypotenuse in a right triangle. So a right triangle, it's this spot right here, from here to here. This is your hypotenuse. So it's the longest side of a right triangle, and it's opposite of the right angle in a right triangle. The legs are the other two sides of the triangle. So here's leg A and here's leg B. And they're interchangeable. The letters A and B just mean that they are legs. A converse, it's a statement formed by exchanging the hypothesis, your science words, and a conclusion of a conditional statement. A conditional statement would be if this, then that. So Pythagorean triple, whole numbers that satisfy the Pythagorean theorem. So we'll find out if three numbers, if they are a Pythagorean triple. All right, so here's what we got cooking here, folks. I would suggest that you have written down c squared equals a squared plus b squared for the Pythagorean theorem. Again, a and b are legs. They are interchangeable. It doesn't matter which one's a, which one's b. The only thing that matters is that you know that c is the hypotenuse, the longest side of the triangle. If I wanted to figure out what a squared was, I would take this c squared equal to a squared plus b. So if I was given a hypotenuse and a leg and I needed to figure out the other one, I would just subtract from both sides to get a by itself. So a squared would be equal to a c squared minus a b squared. So if we needed to figure out a missing leg, we could use that formula instead. So we just manipulated the formula to get a by itself that time. All right, let's do a problem. So we have this triangle. We have a c that we do not know, and then we are given the two legs. So we're going to plug it into that a squared plus b squared equals c squared. So here's what we got to do. Remember, it's from the formula a squared plus b squared equals c squared. If you don't have that stuck in your head by the end of today, it may never be there. So we take 18 squared plus 24 squared, typing it into my calculator, the old trusty green machine here, and 18 squared plus 24 squared is 900. So that's what is equal to c squared. So to get just a c, I'm going to square root both sides. So the square root of 900 is 30. Now I really don't need a calculator to do that part of it, but I should really probably know that. So my unit for c is 30 units long. Beautiful. All right, moving on again. Same kind of a process. Again, we're talking a squared plus b squared equals c squared. A squared plus b squared equals c squared. This time we do not know what b is, so we're going to plug it in. We have to assume that the 9 is the a squared because across from here is the 16, and that has to be the c. So 9 squared plus b squared equals 16 squared. To get b by itself, I have to go and subtract the 9 squared. So this becomes b squared is equal to whatever 16 squared minus 9 squared is. So 16 squared minus 9 squared is equal to 175. So b squared is equal to 175. So I take the square root, 175, and I get 13. So my b is equal to 13.22875656 rounded to the nearest hundredth, tenth, hundredth, look to the next place. 13.23 units would be what B is. Cool? Now we should be able to use some logical thinking here. If a squared plus b squared equals here, we got to know that b is going to be smaller than the hypotenuse. Otherwise, we're doing something goofy. So remember, the hypotenuse is the longest side of the right triangles. All right, let's move on to this next one. Find the length of the hypotenuse. So it's a squared plus b squared equals c squared. So 25 squared plus 60 squared should equal to c squared. So 25 squared plus 60 squared, and then the square root of that number. So we get the answer of 65, which is C. C? Ha! Here's a multiple choice question. See if you can figure out what A is. Remember, you should round to the nearest tenth or hundredth. The hundredth is what they said, if necessary. Let's try another one. We're going to probably need to draw a picture for this little word problem. The diagonal of a television screen is 32 inches. So a TV. This is one of those sweet TVs that's got a little wave in it. So the diagonal is 32. The width is 21. Find the height. Huh. So we can use the fact that this is going to be a right angle, even though my drawing is horrible. So we're going to find the height, which would be either a or b in our a squared plus b squared equals c squared. So we know that 32, which is the diagonal, is the c. So in for c, I put 32, and we're going to square it. And I'm going to pick this 21 to be the a. So 21 squared plus b squared. So I know that I'm going to subtract 32 squared minus the 21 squared to figure out what my b squared is. And when I take the square root of that number, I find out that b is equal to a 24.14 inches. Oh yeah, I had to round to the nearest hundredth, so I screwed that one up. Shoot. Alright, here we go again. We'll try another one. So, Amarita is hiking out directly east from her camp on the plain. She walks for 6 miles before turning right. Oh boy, we're going to need to draw this. Directly east. East is this way, right? So she goes east for 6 miles before turning right and walking 7 more miles towards the south. Turns right, goes 7 miles. How far does she need to walk for the shortest route? Remember, shortest route for any 2 points is a straight curvy line that I drew. So our job is again to find the shortest route here. This would be the way that the bird flies. So we have 2 legs trying to find the hypotenuse of the triangle. So 6 squared plus 7 squared, and then the square root of that, and we get ourselves a very quick answer. So 6 squared plus 7 squared is equal to c squared. And we find our answer to be about 9.22 miles, just like I have in the calculator here. All right. I had to cover up the incorrect words here. A converse of the Pythagorean Theorem. What we're doing here is if we say that c squared has to be equal to a squared plus b squared for it to be a right triangle, we can determine that something is or is not a right triangle by it fitting into that formula. If it does not fit, conversely, we assume that it is not a right triangle, which would be the correct assumption. So a converse is saying that the hypotenuse and the conclusion of that are going to be flipped around. So here we go. Is 7, 12, and 15 a Pythagorean triple? So what we're going to do is we're going to take our 2 smallest numbers, the 7 and the 12, and we're just going to square them to see if they equal to, I'm going to put a little question mark, to see if they equal to whatever 15 squared is. So 7 squared plus 12 squared equals to 193. The square root of 193 certainly is not 15 squared. So they equal to 13.89, not equal to 15. So that means that these lengths are not a right triangle. And we will be able to write that down very easily. If they were equal to each other, we would then say it is a right triangle. And that's an easy way to find out if something is square, because you know that it's making a right triangle, so it's a square corner. And it's an easy way to figure out if it's a triangle, a right triangle. Pretty simple stuff. Here's your open response question. It's your last item of the day, I believe. So plug them into the Pythagorean Theorem, see if it works out. And this is Bermination signing off.